All right, guys, so we're continuing on with the packets that we had yesterday. You can if you want. So the two things that we're going to be looking at today, guys, focus up here, is going to be sum and difference of perfect cubes and or what they're going to call factoring by grouping, or I call it greatest common factor multiple times, is what we're going to be looking at. Now, sum and difference of perfect cubes, we went over this in the fall, and we had kind of talked about the interesting story with dating and how we can remember the signs using that. But we have sum and difference of perfect cubes, so we have a cubed plus b cubed is the sum of two cubes. We have our 3 spots and 5. And we learned that the signs are going to be the same, opposite, always end on a positive note. Is how they follow. And it follows with both of them. Same, opposite, always end on a positive note. So since it's plus, it would be plus, minus, plus. Now for a terms, if we're going to have a squared, and a. Now our b terms are going to go b, and b squared. And it's going to follow this same pattern. Now the same thing is true for our difference of perfect cubes. So a cubed minus b cubed. And what it's going to work out to be is we'll have the same, opposite, always end on a positive note. And our signs for these sum and difference of perfect cubes, when we factor it, is going to work like this. The signs are going to be the same, different, always end on a positive note. And then for our factors of a and b, it's going to be a and b. We'll have a squared, ab, b squared. And we're going to fill in the terms for a and b just corresponding to their places. Now, unfortunately, I can't leave this up here on the board because I'm going to need the space. But I do have it written down here on the whiteboard so that y'all can reference back to it or write it down. So when we look at the sum and difference of perfect cubes, the first thing we need to determine is, are these two here both perfect cubes? And the way we can do that is by taking the cubed root of both of them. So we can take the cubed root of x to the third and the cubed root of 125. And if we get a whole number from taking the cubed root of it, or a whole term, we don't have decimals, then they are perfect cubes. So the cubed root of x to the third is, well, just x. The cubed root and the third power simplify out. Now the cubed root of 125 is going to be 5. And it works out the cubed root of 125 is 5. Now the way we can check this on the math or the graphing calculator is if you hit math, and down in the list you will see the cubed root. So on the graphing calculator you can hit math and it's in that option. I think it's number 5 or number 4. Number 4 is the cubed root. So you can find that, hit enter, type in 125, and it'll tell you that it is 5. So we have whole numbers for both of these, or whole terms. We don't have decimals. So what that means is that x to the third and 125 are perfect cubes. So they're going to be the sum of perfect cubes. We'll have our two sets of parentheses. Any questions on any of this here so far? Okay, now we're going to do the signs. So the signs are going to be the same. So since it's positive, it's going to be plus. Opposite, it's going to be minus. Always end on a positive note. Same, opposite, always end on a positive note are our signs. Any questions on this so far? Okay, now our first term is going to be our x. So it's going to take the place of a in our general form. For when we talked about a cubed plus b cubed, the a is going to be x. So we're going to have x in the first spot. Now over here we're going to have x squared. This here would really be x to the first power. And what goes in the last spot would be x to the 0. But anything to the 0 power is 1. Anything to the 0 power is 1. So there's nothing there. Well, there is something there. It's 1, but we don't write it in because multiplication of 1 doesn't change anything. So that's it for the A term. Now our B term is 5, so we'll put it in place of B. So in the first set of parentheses, we'll just have 5. Now in this place here where x squared, we would actually have 5 to the 0 power, so we don't write that one in. In the middle, we'll have 5 to the first. And the last one, we're going to have 5 squared. So really with those A and B terms and that 5 place one for our quadratic, the terms with A, the powers are going 2, 1, 0, and the terms with B are going to go 0, 1, 2. B's powers are increasing, A's powers are decreasing. Any questions on this here so far? We have one last step and we're done. Well, that's just simplifying it. Now, x plus 5 isn't going to change. Now, we're going to simplify x squared. Well, it's just going to be x squared. For this one here, we just drop the parentheses. The middle one, we're going to have x times 5, which gives us 5x. And the last one is 5 squared would be 25. That's it. That's all there is.
Tyler, Tony, your teacher said you need to go to the library. Tyler, Tony, your teacher said you need to go to the library.
Okay. So really, we plugged in for A and B and then simplified where we needed, squared and multiplied things together. And that's it. That's all we have to do for this year. Any questions on any of this here so far? If we multiplied this back out, let's see here. There we go. Because if I did the multiplication out, so x times x squared would be x to the third. X times negative 5x would be negative 5x squared. And then x times 25 would be plus 25x. Well, 5 times x squared is going to be 5x squared. 5 times negative 5x would be negative 25x. And 5 times 25 is going to be plus 125. Well, these would cancel and these would cancel, leaving us with x cubed plus 125 back where we started. Now, it will always work out that this here, this quadratic, will never factor. When we do sum and difference of perfect cubes, the quadratic will never factor. It just works out that way every single time. So we're done with this one here. So we'll look at the next one here, this x cubed minus 64. So we need to determine if these are perfect cubes. And the reason I'm kind of leaning that way as well, one, that's what we're talking about, and two, x to the third. So most likely we're going to be dealing with a sum or difference of perfect cubes. Now one way we can check it is by taking the cubed root of both terms. Well, the cubed root of x to the third, when the root and the power are the same, they simplify out. We also need to take the cubed root of 64. It is 4. So since both x cubed and 64 are perfect cubes, that means we have a sum or difference. And the reason we know it's a difference is because they're being subtracted. So we'll have our parentheses with 3 spots and our parentheses with 5. Now we can look at the signs. So the signs are going to be the same, opposite, always end on a positive note. Same, opposite, always end on a positive note. So since it was negative to start with, so we have negative, positive, positive. So let's go in with our first term. So x is taking the place of a in kind of the general equation. So we'll have x in the first blank. We won't have anything in this next blank, but then we would have what? X squared, x to the first, and the last spot would be x to the 0. But again, x to the 0 is 1, so we're not going to write it in. And that's all we're going to do with that there. Which brings us to the other term, the one that's going to take the place of b. So we're going to have it go in there. Now, we won't have anything with x squared. The middle one would be 4 to the first. And our last one is going to be 4 squared. Any questions on how we put any of this in? We good with this here? Okay. And now we can just simplify it down, so we'd get x minus 4. Well, x to the second power x squared is, well, just x squared. 4 times x is going to be 4x, and 4 squared is 16. And that's all we have to do for this here. And we're done. Any questions on this here? We good with this here? Yes. All right. I'm going to draw lines. Okay. Let's look at this one next. I'm going to actually add b cubed to it. So we'll have two variables. It's not a big change, and it's not going to change anything really dramatically. It's just going to change the value that we put in for b. So really one way to look at what we're doing, and our first step is taking the cubed root of both of them. We're really just finding the values that go in for a and b for both of these here, and filling in respectively. So the first thing we're going to do is take the cubed root of 27a to the third. And we're going to take the cubed root of 64b to the third. And when you check these on the calculator, don't put the variables in. It's going to throw everything off. Because the calculators, again, these calculators, the graphing calculators, the yellow calculators, these TI-84s, want a value for those variables. So it's going to plug a value in. It's not going to actually simplify the variable itself. And again, we're not taking square roots, we're taking cubed roots. Well, the cubed root of 27 would be, and the cubed root of a to the third is a. Cubed root of b to the third is b. It's nice when we have the exponents match the radical, or the root, not the radical. The radical is just a symbol. Cubed root of 64 we've already seen is 4. So our first term, the term that's going in all the a spots would be, well, 3a. In our general form, the spot that would take the second place, or b, is 4b. 3, 1, 2, 3, 4, 5. Now, since our starting sign, the sign that we have here, we have a sum, our first sign is going to be the same, so it would be plus. The next one would be different, so it would be minus, and we always end on a positive note. So this one here would be plus, minus, plus. Positive, negative, positive. All right, let's look at our terms. Well, the first one is 3a. So in the first spot, we'll have 3a. We won't have anything here. Here we're going to have 3a squared. 3a for the first, and then 3a to the 0. So we just plugged in where 3a goes in those three spots. So 3a, 3a squared, 3a to the first. And we plugged in 3a to the 0, but we just don't have to write it down because 3a to the 0 is still just 1. Anything to the 0 power is 1. And now we'll look at 4b. So 4b will go here. Here we would have 4b to the 0. Our middle spot would just be 4b. And lastly, we'll have 4b squared. Any questions on any of this here so far? You good? Okay. So now we can just simplify. So we'd have 3a plus 4b times, well, 3a squared, 3 squared would give us 9a squared minus 3 times 4 would be 12. And we would just have ab. And lastly would be 4 squared, which is 16, and then we have b squared. Any questions on any of this here? Are we good with these here? Yes? Okay. Now I did throw at least one kind of curveball at you on the homework assignment. One of these is going to have a greatest common factor. So you'll have to pull the greatest common factor out before you can use sum and difference of perfect cubes. But it doesn't change anything. If you have questions on that one, let me know. Yeah, so here's one like it. Let's look at this one before we move on. We can try taking the cubed root of 192 and have a feeling it doesn't work, because I know the cubed root of 81 does not work. So 192 and 81 don't work. X to the third and y to the third do, so we're good there. So we need to see, is there a greatest common factor between 81 and 192? Is there a number that will go into both of those? Well, what numbers do we know is divisible by 81? We know 9 and 3. 9 and 3 would go into that one. So that's what I would try. So we could do 192 divided by 9. But that's not going to work. Because to find out what's divisible by 192 for 3 and 9, well, I can add the digits together. Well, 1 plus 9 is going to be 10 plus 2 would give me a total of 12. So if 12 is divisible by 9, well, that doesn't. 12 does not divide by 9 evenly, but it does divide by 3. Yes, 12 divided by 3 works, whole number. So what that means is 192 is divisible by 3. So we can divide it by 3, which would give us 64 x to the third minus 27 y to the third. Well, now do I have two perfect cubes for this here? Because 64 is a perfect cube, then 27 is a perfect cube. So what we needed to do was we needed to factor out that 3, and once we did that, we got our perfect cubes. Now I went on and just filled those in because, well, we've already had 64 and 27 show up already. Cubed root of 64 is 4, and the cubed root of 27 is 3. Any questions on any of this here so far? Okay. 3 spaces, 1, 2, 3, 4, 5. All right. Let's fill in our signs. So our signs would be negative, plus, plus. Same, opposite, always end on a positive note. So for the first term, so we'd put in 4x. Over here, we'd put in 4x squared. And for the middle one, we would just have 4x. And that's it. Now for the other term, we would put in 3y, 3y in the middle, and then 3y squared. Get out of the way. And last but not least, we just need to simplify this a little bit. Well, 4x squared would be 16. Okay, I'm going to rewrite that because I don't like that. 16x squared plus 12xy plus 9y squared. When we get this all the way simplified. And that's our answer. That's it. Any questions on any of this here? And I'm hoping at this point, now that we've done, I mean, you've seen factoring again. I think this is probably the third time that we've gone over this in some way, shape, or form. It's hopefully getting to be a little bit easier for y'all to see these and how these factor. Yes? And that's what it is with factoring. It's not so much that it's just by doing it. You learn it better by doing it and kind of start picking up and seeing the trends and patterns. All right. We're going to move on to grouping because I feel like y'all have got a decent hand on the sum and difference of perfect cubes. So we're going to move on to factoring by grouping. Or as I like to sometimes call it, greatest common factor multiple times, 2 or 3 times. Because what we're going to do is we're going to kind of group them together. So we normally group the first 2 and the second 2 together. Now, factoring by grouping, or this greatest common factor 2 or 3 times, only works with 4 or more. It only works with 4 or more terms. And it really works best with even amount of terms. So 4, 6, 8, 10. It works better when we have an even number. And what we're doing here, so we're looking at the first 2 terms, and we're seeing, is there a greatest common factor that I can pull out of both terms? Yes. So we won't touch these 2. So we're just going to look at the first 2. So we're going to pull out p squared. Well, p squared out of 2p cubed leaves me with 2p. Now p squared out of 5p squared leaves me with plus 5. So we're just going to pull out that p squared. So we're going to do that. And then we're going to do it again, find the greatest common factor with 6p and 15. Plus 3 because it's going to be positive. Well, if I factor 3 out of 6p, well, 6 divided by 3 would be 2p. Plus 15 divided by 3, if I factor 3 out of 15, I'm left with 5. So I factored p squared out of the first 2 terms. I factored 3 out of the third and fourth term. And I got this here. So any questions on anything we've done thus far? We good with this here? Okay. Well, now we have 2p plus 5 in common with both terms, yes? Because we're now down to 2. And this is why I call it greatest common factor twice or 3 times. Because what we can do now is I can factor that out of both 2p plus 5, factored out, of our first term leaves me with just p squared. And when I factor it out of the second one, I'm left with just plus 3. And that's all we have to do with this here. Now we can look and make sure that once we're finished here, so p squared plus 3, well, okay, well that won't factor because we don't have a sum of perfect squares. And even if it was minus, well, 3 is not a perfect square, so we're done. This is as simplified as it can go. And whenever you're tackling these, and we'll see these in a little bit later on, if the numbers are hard to see what could be factored out of both that would work well, try to find the one that's easier to work with and match them up. Because once I get, let's see the highlighter. One set of parentheses done, I factored something out, I can use it as a template for what the other one's going to be. Because once I got 2p plus 5, I know that the other set of parentheses had to be 2p plus 5. So once I get one, I try to make the other one be the exact same. Does that make sense? Now, if for some reason you get the first set of parentheses and the second one's not matching up, re-look back at the first one and see, is there another greatest common factor that I could use? There could be a bigger one we just missed. All right, let's look at this one here. So again, with factoring by grouping, we're going to look at the first two terms and the second two terms. So looking at 3n to the third and 4n squared, is there a greatest common factor between these two terms? N squared. That's the only thing that they have in common. So if I take n squared out of 3n squared, I'm just left with 3n. We didn't do anything with the sign, so it'll still be minus. N squared out of 4n squared will leave me with 4. So what I have is 3n minus 4, yes? So what would I need to factor out of 9n to get to 3n? I need to factor out of what? 3, yes? What would I need to factor out of negative 12 to get to negative 4? 3, it'd still be positive, yes? So that's kind of a way also. It helps us figure out, do I need to factor out a negative? So we're going to factor out just a positive 3. Because 9n, if I factor 3 out of 9n, or 9n divided by 3, will leave me with 3n. 3 factored out of 12, or 12 divided by 3, will leave me with my minus 4. Now again, we have 3n minus 4 in common with both, so we can again factor it again, factor that out of both. So we're going to factor out 3n minus 4 out of both of these terms, which leaves us with what? N squared plus 3. And that's all we've got left. I'm good. Any questions over anything we've done so far? Any questions over any of these here? Are you ready for the next one? Yes? Okay, let's look at this one here. 12n cubed plus 4n squared plus 3n plus 1. So we're going to factor this by grouping. Group the first two terms, second two terms. So looking at the first two terms, what's the greatest common factor between 12n cubed and 4n squared? So it'd be 4n squared. So 4n squared, if we factored out of 12n squared, or 12 divided by 4 would give us 3n. Mm-hmm. So we took 2 n's out of n cubed, which just left us with n. And since 4n squared factored out 4n squared, since we factored everything out, we're left with plus 1. Because whenever we factor everything out completely, it's just going to be 1. We'll never factor out something and get 0. Plus. Mm-hmm. Because this is already matched up we don't need to do anything with it because it's already there. We have a greatest common factor set up for us already. So since we have 3n plus 1 in common in both, we can factor it out. So when I factor 3n plus 1 out of our first term, the only thing that's left over is our 4n squared plus, well, we just factored everything out, yes, because we factored in 3n plus 1. So if we factor it out completely, the only thing that's left over is 1. Because again, anytime we factor something out completely, the number that we write in is 1. And that's it there. And that brings us to the last problem that we're going to look at. This here is the last problem that we're going to look at today. So we have these two sets of numbers here. Now it's probably a little bit challenging to see what is the greatest common factor between 224 and 56. That's a little bit hard to see because, I mean, 224 has a lot of factors. So we could factor out 7a, because both of these terms have a, yes? So we could factor out 7 from 224. And if we factor that out or divide 224 by 7, what is that, 32? We have 32, if I can write a 3, 32z plus 7 out of 56 would be 8. 8c. Because there is a greatest common factor, but what I'm also looking at is there any way that we could pull a number out of 12 and get 8? Or not 12, 21 and get 8? No, that'd be a little challenging, wouldn't it? So we're probably looking at something bigger than this. So it's kind of, these 224 and 56 is a little bit challenging to look at, isn't it? Seeing the factors? So let's sit it on the back burner. And let's look at 84 and 21. Well, the only factors of 21 are 1 and 21 and 3 and 7. So we look at 3, 7, 21. Wait a minute. Well, 21 going to 84? How many times? 4. So I could factor 21 out of this here, and we do 21, not just 21, but 21 what? 21 y. Okay, so that is a greatest common factor, but what do we notice about the signs? They're both what? Negative. Are the other two negative? Or the two we tried to start with, 224 and the other one? So most likely, whatever is going to go inside these parentheses here should be what? Positive. So to change it from negative to positive, we need to factor out a negative. Is any time the second set of factors have opposite signs, if one of them's positive and negative or negative and positive, they're both opposite of what the first ones are, we'll pull a negative out to adjust for it. Now, negative 84, if we factor out negative 21, well, the negative and negative would make a positive. 84 divided by 21 would give us 4, and then we have z. Well, 21, negative 21, if I factor out a negative 21, it's going to be plus c, because c is the only thing left there. Only thing we didn't pull out. Questions on this here. So what does that tell me about the first set of parentheses? Now what's inside the parentheses here should be 4z plus c. Yes, if this is going to factor, we need it to be 4z plus c. Because what's inside those two sets of parentheses need to be the exact same. Well, it works out. The number that will go into both of them is 56. The greatest common factor is 56. Well, we have 4z plus c and 4z plus c, so we can factor that out of both of them. And if we factor it out, what we're left with is 56a minus 21y. And that there is our answer. Any questions on any of this here? Are we good with this here? Okay.